Students, now let me discuss about conservative and non-conservative force. Okay, and this is a very important concept. This concept is not useful for this chapter work per energy, but this concept will be very helpful for you when you will study electricity, electrostatics basically, and gravitation. Okay, in 11 course you will face a gravitational force, and in class 12 you will face the electrostatics, that is the electric force, and that's are the some example of conservative force. And sometimes we have seen some non-conservative force also, like frictional force, viscous force, etc. Okay, so now let me discuss about the concept of conservative and non-conservative force first, so that you can understand very easily. Okay, so what is conservative force? So let me first define the conservative force, then you can understand easily non-conservative force also. So what is conservative force? What is conservative force? Suppose we have a 2 point. Okay, this is just point 1 and this is point 2. Okay, so suppose the work is done along this path. Okay, along this path from here to here under some force F. Okay, so let me take a force F. Okay, let me denote the force as a vector. Okay, so under this force, let me say that under this force a particle is moving from one point to this point number 2, and for this case the work is done by this force F, and let me say the work done is W1 for this case. Now with the same force, if work is done along another path like this, suppose the work done is here W2. Similarly, if suppose we choose a straight path from 1 to 2 like this. Okay, and let me suppose that the work done along this path is W3. Okay, now if you see that work done in all these three paths, that is W1 is equal to W2 is equal to W3. If you see that W1 is equal to W2 is equal to W3, okay, then you can say the work is done under this force is independent of path, because it does not depend along which path the work is done, but the magnitude of the work done is same for all the three paths. Under this condition, this F is called conservative force. F is called conservative force. Okay, so the definition of conservative force is this, that a force is said to be conservative if the work done by this force or the work done under this force is independent of path. Okay, so if the work done does not depend on the path, that is in each and every path work done is equal, that is W1 is equal to W2 is equal to W3. So in this condition you can say that this force is conservative in nature. Okay, so this is just the concept of conservative force, and we have some example of conservative force, more example, that is gravitational force. Gravitational is also conservative force, we will see later on. Gravitational force is also a conservative force. And obviously if you talk about just electrostatic force, this is also a conservative force. Electrostatic force, this is also a conservative force. Okay, and this is the first property you can say under conservative force. And the very second property is that, which follows from this property, that if you take like this a path, this is from A to B, and work done to this path is WAB. Now if you take another path from B to A, so you will have the work done WBA. Now the direction is different. So if the force is conservative, then the magnitude of WAB along this path and this path will be same. So if you take this path along this direction, suppose along this direction, and this is WAB and this is also WAB, this will be same. But now if you take the direction of this path in opposite direction, then it will be minus WBA. In that case the work done from B to A, so you can denote it. So if this is A point, this is B point, so if this is WAB, then obviously from when you talk about B to A, then it will be minus WB, minus WB, B. Okay, you can say WBA, and that will be minus WAB. Actually, I can see that this is WBA, and WBA is nothing but minus WAB, minus WAB. Okay, okay. So you can say that the work done along this path. Okay, so WAB is equal to actually minus WB, minus WB. From here you can say. Okay, so you can take WAB plus WBA is equal to 0, So if you go from this point to this point and then this point to this point, the total work done along this complete cycle is 0, So this is also another property of conservative force, that under conservative force the total work done along the closed path is 0, and you can define the work done. We know the work done we have the expression of work done is just we have dW is equal to F dot dr. Okay, so W is equal to integration dW, so that is nothing but integration F dot dr. We know this is the expression of work done. Now if you talk about closed path, then this can be written as like this: closed path F dot dr. But this closed F dot dr will always be 0 if and only if this F is conservative force. So what are the properties of conservative force? First, obviously the work done in each and every path, if you choose, if your initial and final point are same, then you can choose infinite number of paths between these 2 points, but you will get always same work done if F is conservative force. And the very second one is that you will get the closed, if you want to find out the total work done along the closed path, so work done along closed path will be 0, along closed path will be 0. And third one, that means that is closed line integration. This is actually line integration. Okay, so closed line integration F dot dr. So in advanced class you will see that this is called line integration. So this is just 0. Closed path line integration F dot dr is 0, always 0. Okay, and this will imply that from here we can see if any conservative force, if there is any conservative force field, we can write closed path line integration F dot dr is equal to 0, and under this conservative force always we will see there is a scalar quantity. Okay, you can say there is scalar quantity u such that F is equal to minus du by dr. We will see later on. This u is actually called potential energy. And this will only resides in the field of conservative force, within the field of conservative force. So it cannot exist without conservative force. So whenever there is a conservative force, there is closed path integration, the total work done along a closed path is 0, and then you will obviously get from here a potential a scalar quantity like this u, which obey this relation F is equal to minus du by dr. Okay, and this can be proved from this expression, but here in this class I can't prove this. Okay, because this is the beyond of the scope of your syllabus. But you should remember that whenever you will get this kinds of relation, closed integration F dot dr, then you will get this. Okay, I will be repeating this thing again when I will discuss with you about potential energy. Okay, so this is the different part of this lesson. Okay, but here these 3 important property is necessary for conservative force. But if the force is not conservative, then obviously these 3 are not equal, and obviously this F dot dr will also be not equal to 0. Okay, so in that case there is no existence of potential energy. And what are the example of this non-conservative force? Non-conservative force, like we have frictional force, any dissipative force like frictional force. Another one is viscous force. Okay, these are actually non-conservative force. Okay, so these are the actual properties of conservative and non-conservative force. Okay, so now let me see one or two problem that F dot dr is not independent of path. You can see. So F dot dr or W is actually depend on initial and final position. Only depend on initial and final position. But it does not depend on the path along which you are following. Okay, along which the work is done. Along which path the work is done, it does not depend on that. It only depends on initial and final position. And these are the consequence of this closed line integration F dot dr, work done along path will be 0. Okay, these are the consequence of this thing. Okay, so let me solve one or two problems so that you can understand the thing. Okay, so let me solve this problem. Okay, so here the problem is that an object is displaced from point A. So the coordinate of point A is given, to a point B is given, under constant force F is equal to this. Find the work done by this force. So what is the work done? Work done is always integration F dot dr. Okay, integration F dot dr. This is the work done. And what is F here? F is given as 2i cap plus 3j cap plus 4k cap. Okay, 4k cap. Dot, what is dr? Dr means in two dimension, we know in two dimension r is what? R is actually xi plus yj. So what will be dr? So dr will be dxi cap. Okay, dxi cap plus dyj cap. So you can use this. Okay, so it will be dxi cap plus dyj cap. Now if you take this dot product, then you will get 2dx. Okay, so this is 3 dimension. Okay, so 3 dimension, there will be another term that is dzk cap, and here is zk cap. Okay, this is 3 dimension because the point is 2, 3, 4. So it will be plus dzk cap. Okay, it will be 2dx plus 3 dy plus 4 dz plus 4 dz. Now let me do the integration differently. Okay, now x is varies from here, you can see from 2 to 1. So x is varies from 2 to 1. Okay, similarly y is varies from 3 to 2. And z is varies from 4 to 3. Okay, so you will get 2 into 1 minus 2 plus 3 into 2 minus 3 plus 4 into 3 minus 4. So you will get here 2 into minus 1 plus 3 into minus 1 plus 4 into minus 1. So you will get just minus 2 minus 3 minus 4. So it will be minus 9 joule. So the work done will be minus 9 joule. And it does not depend along which path the work is done. It is only depend on this initial position and the final position. You can see from this problem. Okay, it will only depend on initial and final position. It does not depend along which path you are going, along which path the work is done. It does not depend on this. Only depends on the initial and final position. This is actually the definition of conservative force. This is the property of conservative force, you can say. Okay, so now let me see the next problem. Okay, so here the problem is that an object is displaced from the position r1 is equal to 2i 3j. That means the point is x, this is x and this is y, or you can say this is x1, this is y1, to r2, that is this is x2 and y2, under a force F is equal to this. Find the work done by this force. Here the force is variable. The first problem the force was constant force. So here the integration will be little complicated. Okay, but the process will be same. The W is equal to integration F dot dr. We have this kind of situation. So here F is what? F is, we have to put just 3x square I cap plus 2y j cap dot dr means dx I cap plus dy j cap. Okay, so this is the integration. So it will be just 3x square dx, okay, plus 2y dy plus 2y dy. So now you have to put integration. Okay, so this is w. Now x varies from 2 to 4, the limit will be 2 to 4, and y varies from 3 to 6, so you will get 3 into, here you will get x cube by 3, okay, and the limit will be 2 to 4 plus 2 into y square by 2, and the limit will be 3 to 6. So you will get just this 3 will be cancelled out, and it will be 4 cube minus 2 cube. This 2 will be cancelled out again, and it will be 6 square minus 3 square. Okay, so it will be 4 cube means 64 minus 8 plus you will get 36 minus 9. Okay, so you will get just what you will get, this 64 minus 8. Okay, so w will be 6 and it will be 5. Okay, so 56 from here, and from here you will get just 27. Okay, so you will get 7, 6, 3, 8, so 83 joule. Okay, yes, 83 joule. Okay, so this will be the work done, and here also the work done does not depend on the path along which the work is done, but only depend on the initial and the final position. Okay, so this is how you can solve the work done, the problem of work done involving conservative force, and this force may be actually constant or maybe variable, but here the force is given in such a way that the variables are separable already, because you can see here that here the variables only x and here the variable only y, but this is not necessary actually. Please keep in mind, this is not necessary. Sometimes if they give the force in this way, they can give actually, if they want, they can give the force in this fashion. Okay, suppose F is equal to 3x square y I cap plus 2y, okay, plus 2y x j cap. They can give this also. Okay, but in this situation you cannot solve the integration without knowing the actual path along which the work is done. So in that case you have to they give you actually in that case the relation between x and y. Suppose they give you the relation between x and y is equal to x square, then you have to put, instead of y, x square, and instead of dy you have to put dy is equal to 2x dx. So you have to convert this integration either in x or in y by using the equation of curve along which the work is done, along which path the work is done. The equation of this path will be given in that case if the variable are not separable actually. If the force is something like this, the component of I cap and the component of j cap involve x, y both. Here you can see the component of I cap involve only x and the component of j cap involve only y, but it is not necessary always actually. They can give the component of I cap also in terms of x, y, and the component of j cap also in terms of x, y, the coefficient of j cap in terms of x, y. So in that situation what will happen? They will give you another extra equation involving x and y. From there you have to substitute, but these kinds of problems are not asked generally in 10+2 level. Okay, because this is the case of line integration actually, which is in your BSc syllabus, Okay, so don't mind. So they will always give you like this, or they will give you the constant force. Okay, but if they give you, then you can do it. Suppose let me solve this problem, then you can understand. Suppose let me solve this case. Okay, let me solve so you can understand. Suppose f is given instead of this, suppose f is given in this way, 3x square y I cap plus 2yx j cap. Suppose they give you this. Okay, then what will be your w? Integration f dot dr, then you will get 3x square y dx plus 2yx dy. Will get in this way, but they will give you another extra equation. Suppose they give you, they have given y is equal to x square, then what you have to do? You have to take dy, that will be 2x dx. Then you have to convert y in terms of x. So you can easily convert, that is 3x square into, in place of y you can substitute x square plus 2 into again x square into x, instead of dy you have to put 2x dx. Okay, so 2 into x square into x, so you will get here 3x to the power 4 dx plus 4x to the power 4 dx, 4x to the power 4 dx. So you will get in this kind of situation. So now the problem will be very easy, because it is just 3 plus 4, that is 7x to the power 4 dx, and the limit of the integration will be just in terms of x. So x will vary from 2 to 4. So you will get this kind of situation, 2 to 4 x to the power 4 dx. So they can give in this way also, but generally these kinds of problems are not asked in 10+2 level. Okay, so in this way you can, but if they ask, you can solve easily, not a very difficult problem. Okay, so in this way you can solve the problem.